Ashmika Cutter. Today we are going to discuss about communicating sequential process. Communicating sequential processes is a formal language which is used to sequence process of multiprocessor machines. The key features include non-buffered message passing, like there is no buffer included, and the explicit naming. Explicit naming is like using source and destination names while message passing. And CSP uses guarded commands. Guarded commands we'll discuss later. Uh, Now we are going to discuss about CSP's approach. CSP's general mechanism, like exclamatory mark is used for sending message and question mark while receiving the message. Like here there are two messages, message A and message B. Message A computes a particular value, and and comes with a value x, and it sends this output to source process. So here source process is b, so we denoted b. So since we are sending x and the output is x, and at b this value is x is received, and from which process, destination process, it is a, and value y is computed. So this way we represent CSP's approach. What is the problem? Like here, for example, receive q message, there are three process q, r and s, trying to send message to process p. But since the message queue receive has only queue process mentioned with message, so P could receive only message from queue. R and S trying to send message would fail. This is the main problem, and CSP generally denoted as A, some boolean expression, B, and the meaning of this command is like A and B. It checks for if A and B are type matching, like if A is real, B is real value, A, this command is true. And suppose if A is real and B is character, this command fails. And it is also time dependent, like at some particular at some moment A could be real and B could be real, and after several computations A could be character and B could still remain real. After that, which this command becomes failed. So time dependency also matters. What are parallel commands? Parallel commands are like executing all the commands in parallel, like this, execute this command and then this command and this command. The main requirement is this command needs to be executed. This command, either one of this command should be successful, then only the whole command is successful. How are IO commands represented? Like these are the input commands, these are the output commands, and this is source process to which we want to send the message, and this is the target value which we want to send. Like keyboard, screen has suppose screen process, there are two processes, screen and keyboard. Screen has computed some value m and wants to send it to keyboard process, so it is denoted this way. And while at keyboard process, it is receiving the message from screen and it computes a value average as input. So the IO commands are succeeded when suppose process P executes an input command, specifies process Q as its source, and process Q executes an output command and specifies process P as its bind. The target variable in the input statement matches the value in the output statement. This is the main requirement, and these are the parallel alternate commands. This specifies that these two command list 1 and command list 2 to be executed in parallel. Like, what are guarded commands? Guarded commands like v greater than 0, client question mark, and process p. These are known as guards. And this v minus 1, decrement the v value. This is the command. Like, when guard is successful, do this, decrement the v. This command, this indicates that if v is positive, decrement v, and when message is received at message, this message process p. This guard could be boolean expression. Like, let us look at an example: x greater than y greater than m, and assign x to m. This square brackets represent that OR operation. This is one command. And if y greater than or equals to x, x greater than m, then assign y to m. Either x greater than y, then assign x or y to m. Alternative command, like we discussed before, the requirement of alternative commands is to either one of the command to be executed, and shorthand notations include like I is equals to 1 to 100. Instead of writing x of 1 to x of 100 many commands, we can just include I is 1 to 100 notated in a single command. Repetitive commands like this, like in for loops in any programming language, from I0, this is represented by asterisk value. This command executes until I is greater than 0 or positive I. If in case I is less than 0, then this command fails. Buffered is like, we maintain a value from 0 to 10 until this value, this command executes. Like, producer receives message only when buffer is full, and consumer receives. Producer do not receive the message when buffer is full, and consumer do not receive message when buffer is empty. For this we use bounded buffers. So in this way we use CSPs, IO commands, alternative commands, repetitive shorthand commands to write a process commands, and to achieve simplicity, composability, and concurrency, which is main objective of CSP. So CSPs are more of mathematical, algebraic instead of theoretical. With this CSP, the concurrency of processes is achieved. This is all about CSP. Thank you.